All right, so here we've got one. Limit as x approaches 0 of e to the 2x minus 1 minus 2x over x squared. So what do we have? Well, get our pencil to work here. Will work. That's going to be e to the 0, which is going to be basically 1. Minus 1 is 0. Minus 2 times 0 is 0. So we get 0 in the numerator, and then we have 0 in the denominator. So because of that, that's the indeterminate form, so we can use L'Hopital's rule. So now that means let's take the limit as x approaches 0 of the derivative. So the derivative of e to the 2x is going to be e to the 2x times 2, because we have derivative of e to the x is e to its x. But then we have this inside piece, so the derivative of that is 2. And derivative of minus 1 is 0, and then we have minus 2 over, this becomes 2x. Okay, so now what do we have? Well, now we have e to the 0, which is going to be 1, times 2 is 2, minus 2 is 0, and then 2 times 0 is 0. So we have the indeterminate form again. So guess what? We can take this next derivative again. So now we're going to take the limit as x approaches 0 of the derivative of this. Well, if we need to, we can rewrite this as 2e to the 2x minus 2 over 2x. That way we can see what it is. Now we're going to take the derivative of this piece again. So that's going to be 2 times e to the 2x times 2. Well, the derivative of minus 2, that just goes away. And then the derivative of 2x is going to be what? Well, that's going to be 2. All right, so now if we do that, let's cancel stuff. Well, that 2 will cancel that 2. And so now what do we have? We have 2e to the 2x. Well, if we plug in 0, we get 2 times e to the 0, which is 1. So we just get 2. And that would be our answer. So this is a case where you have to use L'Hopital's rule twice, take a derivative one time, and then you have to take it the second time before you actually get your limit. And so that happens sometimes. You have to take it multiple times. I've seen up to 6 or 7 times before you actually get to the thing. And it all depends on really this denominator. If that denominator is x to the 6, then you're going to have to take 6 times to get down to where you get rid of the x's in the denominator and you just have a number down there. And so that's going to be kind of a key thing to think about when you're doing these. All right, so let's stop there and we'll come back for some more.